Hey, once again, thank you very much for joining us. I know your session is especially hard. It's the last session of the day on a Friday. I'm sure you're wanting to go home over the weekend and enjoy yourself. So I appreciate it even more than everybody else's session that you're making time for us. The floor is yours. If you'd like to take questions as they're coming in, you see them in the chat, that's fine. If not, at the end of it, we'll open up the floor for any questions. You are good to go.
Thank you. And thank you for organizing. So let me just present this. I'm going to be presenting in English. I know there are also Turkish audience here. So if you see yourself fitting asking questions in Turkish at the end, I can accept that. But the main conversation will be in English here. So I hope that's okay. So we're going to talk today about the real world power platform where we have patterns and pitfalls. So the current implementation of systems are gradient. It's implemented over time. Some systems are agile, some systems are waterfall, right? We come to a point where we might need to evaluate our architectural models where we have maybe something working or breaking or scaling over time. So we're going to go through some of these scenarios. I'm going to overview the structure. We are going to touch base some topics. It's mainly focused for architectural details, but I hope you'll find it useful and real time because mainly also it's based on my experience over time. Just 1 second. All right. So first I'd like to mention about me. I'm actually based in Sofia. And this is a guest event for me, I guess. But I work as Microsoft Dynamics technical lead right now in the Coca-Cola company, and I'm focused on Dynamics 365 and Power Platform solutions. So when it comes to the tech topics, you can ask me questions about Power Apps, Power Automate, Power Page, Dynamics, and anything comes to actually around these. And I've been working for these systems and this stack around over 8 years. So I had a different experience in different companies and with different in different scopes. I do hope that it will give you some also perspective of what I've been through and what the projects are going through. So let's start. So we're going to start looking for a system which is a high level. We're not going to dig deep in these. It's not meant for technical details, but I wanted to give some sample and us to go through there. We have a system which is a sustainable system. And this gives us a picture where we have different users interact with different layers. And we have these users, which are, let's say, support agents use a model-driven app. We have some employees are using the external portal for Power Pages. We have a website where we go through our tasks. We have some Canvas apps. We can use them for different approaches. Here, let's say a task app. And we'll connect these to Dataverse. And we have automation and orchestration at the end, which is with Power Automate and Copilot. So this system will go more in detail here, where we have the layers and the tiers that you can see. So engagement happens from different portals where we have external or internal users and different purposes. We focus on keeping Dataverse as our relational structure where data sits in everywhere. And we'll touch base or other topics like orchestration in intelligence, but you can imagine a system in big scope can have a lot of integrations as well. So many Power Platform systems are working very well at the beginning and become harder to maintain as growth. And this usually happens when the logic is spread across multiple apps and flows without clear structure. By separating interfaces and keeping Dataverse as a shared data foundation, we prevent the complexity from becoming unmanageable. So this allows the system scale and evolve without losing reliability. You can see a layer structure where we have everything clearly defined as the previous slide, where we have responsibilities are clearly separated. And as much as we focus on building that, building a system which can be maintained, it will help us to scale at the end as well. So we're going to go through a month-to-month approach where we have an understanding of a system is newly built, where month one is everything works perfect. Within this, we actually have a data volume, probably a small data volume in the beginning. Logic is very simple. There are numbers of users limited. And we have the apps load instantly, flows run quickly. The system is easy to change as well. So this stage, we are not actually having an architectural tested properly because we don't have the system operating under ideal conditions. So we can trust the system to build to work, right? We don't necessarily face an issue where we will have an issue with the design. But in time, where we move, we can start seeing some strains. So around month 6, let's say the system experienced some real work pressure. Now we have more users which are accessing daily. We have more data stored, more automation gets added to support these new requirements. The system is evolving. It's an ongoing project. And where we start seeing actually first weakness begin to appear. Screens will have longer loading times. Flow will have interaction which are more complex now. We will have it will have difficulty with doing small design decisions where we're going to have issues. System still works. We don't see an issue here. The system will not work, but it's no longer a effortless system. So we need to start thinking that at this point architecture begins to matter, and we move forward. So around month 12, we have system working, but something important has changed. It's no longer easy to change. Performance issues appear to more frequently, but more importantly, small changes start to have unintended side effects, which maybe some of you saw this already, right? We have some systems, we start having some issues, some production issues start appearing, might be based on implementation or wrong implementation or just complexity of the things that are being built. So this is the point. We need to take more time to understand how the system behaves before making any modifications, because we have already an ongoing system for a year, right? And this creates hesitation for a developer team. So we need to be more careful. We need to act on small changes, and the things that we can do can also create some unexpected problems. And this is a point we need to be moving more, is that we will consider that how to maintain this system and how to make it so that it actually scales better after this. So we came to month 18. We have a year and a half passed, right? So the biggest change is not technical right now, it's psychological. Confidence in the system has become lower. So fixing problems taking longer time, adding new features feels more risky. And automation sometimes behaves in ways that are difficult to explain. So the system still works, but team no longer fully trust it. This would happen if the system is not built in an ideal way, right? We would face an issue to touch any components being built over time or any dependencies that build over time. So we would have a conversation at this point that about redesigning and rebuilding parts of system begin. Not because the platform is failed. Our system is working partially or fully, or let's say maybe not fully, but at least in a main focus. But because the architecture didn't scale with the system growth, we have now an issue to think whether we should build this project from draft or at least some portion again. We come and try to do enhancements, improvements, and so on, just because the way that we build is not scaling enough. So let's move forward. So we touch base from a structure where we go from 1 to 18 months. This is an hypothetical situation, of course. It might be that you would not face an issue within that early stage, or it might be that you're already in a serious problem and considering to rebuild some systems. I think I had similar examples also in my work. There were times that I been built a system which was considered to completely draft out and be rebuilt because a structure is being built was not scaling enough and the data was not stored properly. So there are different points it can become when a system is expected to evolve and grow and work easy on it. And there might be different issues, right? These are not one or another. We will see some scenarios, but just want to highlight that we would not expect all these or one of these to happen particular. But we can actually come to a point that most of the system, they don't fail in the beginning, but the solutions fail slowly. Not because they stop working, but because they are becoming slow, unpredictable, and risky to change. So this is where we actually wanted to touch base from 1 to 8, where we have the points. So we touch base different things, but we can say that some of the early architectural decisions decides how the system will work. So we need to be focused on things which will affect the performance, maintainability, reliability, and how easy to save make changes. And any good architecture will allow the system to grow without becoming harder to maintain, or at least it will ease the work, let's say. But a poor architectural model makes every new feature increase complexity and risk. So any questions till now? I just want to stop for a second and see if there is anything that takes any attention. Please jump in. If not, we'll
No, but
continue.
the googly eyes are pretty cool.
Yes, that's to dig deeper for our topics. Decided to bring some attention here. So from this point onwards, we're going to touch base 10 different pitfalls and patterns. And these pitfalls and patterns will give you some perspective. They don't mean that they're exactly what's happening as I touch base, but I would say that there are many topics that you would face an issue either in early stage of your development career with Power Platform or in a project. Doesn't mean to be that you're experienced or not, but we'll start from data where we touch base and everything. And actually, I had an experience like this within Dataverse, which was very hard to work with and hard to change. So I'm going to also mention that. So one of the things that has been approached in data, actually a system is data base and data origin, right? So we need to make sure that we store this data properly. But there would be a system that's some of the very relational data is being considered as text. You can see that there are some examples here, department technician category for such a support request table. I would assume these would be relevant examples. So at the beginning, storing this data text feels simple. There is no issue, right? The text doesn't create real relationships. It's just structure, no structure behind. But the system grows and small differences in naming start to appear, and the platform can no longer reliably determine ownership, apply things like SLA rules, or group data correctly. So this is usually where the teams notice the reporting issues and automation behaving inconsistently around month 6. And the root problem is that the system has data, but it no longer has structure. And without this structure, the platform cannot scale. So this is very important start point for many things is built in Dataverse. I would say the data first approach applies. And many of us would spend a lot of time to understand that data, to just build a system where it's consistent, reliable, and actually structured enough from the data perspective, where we have this proper approach where everything is related as a relation, with a database behind, so that we can scale this data and work properly. So the pattern to this is to create a relational backbone. And within this, we store this data, plain values, structure their respective tables, right? We actually create a relational structure. This means that platform can understand who owns this request, who is this technician, what is this category. So automation becomes more reliable with this, and reporting becomes more consistent. Any system, like even a Copilot usage, can reason this system correctly and better. So Dataverse is no longer is just storing data. It's actually understand the system, how the system is behaving and connected. And this is a very critical point to start for main systems in the Power Platform. So our second point, and pitfall, is a schema drift problem. Over the time, the schema changes accumulate and new columns can add without clear ownership. We could have similar concepts, similar approach for multiple forms. Automation becomes more fragile because assumptions are no longer reliable, and this is a schema drift. And we can expect, I think, again, an ideal world, let's say, this could come as Mount 12 maintenance complexity to us. Pattern to this is to keep the data model clean, which means that let's say we have department where we might mention department, it would be exist as department, support department, department name. Over time, our automation and reporting will not know which one to trust, which one to work with. So the fixes on this is to store something at one place only, department to exist to department table, and the support request references is using this as a lookup. So we create a relationship. And when we have a new requirement appears, we extend this relationship instead of creating duplicate relationships. So we would avoid as much as in this system to create additional relationship for the same purpose, or we will try to do repurposing for the things we already have in our hands as much as is logical. In this way, we will not end up with unnecessary relationships where we have the same data as we mentioned repeating. We would not properly differentiate that when it comes to automations and reporting, and we mentioned also Copilot. So focus on keeping the schema stable and prevents maintenance problem later. So we have another pitfall here, the metadata execution trap. I'll mention this a bit different. So we have a logic in the beginning, which is working fine, harmless. This is very beginning of our end, but we start having a request for validations and we start adding business rules, JavaScript, loading related data, even on the more dynamic way. And all this logic runs on the client every time this form, the support request form is opens. And this usage increases with the daily usage, like that comes to the system, the execution grows. So the form will become slower, not because of Dataverse, right? We have the data structure as is right now. We're not touching that, but because there are so many logic runs happens on a user session. And this is the point there will be a performance degradation begins. So once we have this, we need to move for thin forms and strong Dataverse. In order to implement this, we should focus on not computing a ticket, but rendering a ticket, which means that we should keep some of the calculations, like calculating stuff like SLA timings and so on the calculate columns. There is a feature for us to use on this. And any critical validation we see is instead of trying to do in a front end, right on the client side, we should try to do this as saving time on the back end with plugins. So this will help us actually reduce the form load. And any heavy related data that we show, like a ticket can have a timeline, should unload only when we need. So in order to arrive to this point, we should consider what to load on a form, how many grids to use, how many tabs to use. There are a lot of features in the form which give us a bit flexibility in the sense of how the form loads, how to approach that so that we don't actually overload our form. And it's very critical to achieve this because I did see cases where there were forms so slow, so overloading taking so much time to load, especially on model-driven app, right? That's one of the most common thing. And a client would come to you and say, like, this takes too much to do an operation. They need to work with, let's say, in different pages during the day, many recurrent, like so many pages and records. So we need to focus on how to create a faster form load. We have another pitfall here, which is a trigger storm. So maybe this is one of the most common one, actually, I would say. We have a lot of flows, right? So we have one flow, let's say, to sense notification, another calculates SLA, another can integrate with some external systems. There are so many systems that I saw that flows are very main focus. One of the reasons I believe that it's considered as more low code right now, right? And it's easier to implement if it's not a complex structure, which makes sense. And it might be that these flows work independently, but they might react sometimes in the same table, right? And if we build such a structure, this creates unpredictable system behavior sometimes. Let's say that everything is touching our support requests table, where we take the example. And it will be very hard to troubleshoot. It will get difficult over time because there is a logic spread across multiple flows within this way. If we use the same table and focus on doing different operations in different places, there might be another way to approach these, that there might be different flows within updating same record. That's actually one of the main, also very often example, where we need to very much be careful how we're doing that operation, because it would impact very much the way that data is being triggered and create loops and deadlocks. So let's move with the pattern on this. So we should try to approach, of course, an orchestrated automation here. This will help us to build a structural execution. It's not about fewer flows. And the key principle here is separating responsibility between plugin Power Automate, also making sure that which layer is doing whatever is best. So the first layer of operations is transactional boundary. This is where plugins will operate better. We will have synchronized plugins to work on, let's say, support requests to create an update. You could do some things like validation. You can prevent invalid state transitions. You could ensure required relationships exist, because plugins will trigger inside Dataverse transaction. They will also guarantee that there will be no invalid data enters the system. And our second layer after the plugin runs within this scope is orchestration. So instead of having so many flows reacting independently, same update, a single orchestration flow can work, and it could be responsible from a ticket lifecycle. This flow will evaluate what changes and decides what actions needs to happen next. Actually, this prevents a situation where multiple flows compete each other and execute an unpredictable order. As I mentioned, that happens very much where we have doing the same operation. There are multiple flows doing the same operation in the same record, and you would have a loop where you would not able to break. So it needs to be very carefully designed. We have a lot of things that can be done. One is that actually you create specialized child flows to specific responsibilities. This could help you to, let's say, to sending notifications, calculation, or if you need to synchronize some things with external systems. And if you define these child flows with a clear and isolated purpose, right, this will make system easier maintain and evolve. And one of the most critical thing I would say is the error handling. So execution of the flow should have scope and retry logic. We should ensure that failures of external integrations will not break the core system lifecycle. And the structure restores predictability to the system. So validations should happen at the platform level. Coordination happens in one place. Execution happens in controlled, isolated flows. And this will allow a system to scale safely beyond month 12 without becoming fragile and unpredictable. And this would be one of the main, I think, point for many systems where things start also scratching. Like we should have a very good automation system in many projects. And you can see a similar small example here where the plugin enters, orchestrator flow comes, and it would do different actions. Of course, there are many things that plugin can do. There is no limitation on that, but flow gives flexibility right now. So for many async process that being done with plugin is actually being moved to Power Automate in many environments. So our next topic is the client-side security illusion. The portal hides, so we are touching base here, Power Portal, just to mention. The portal hides and takes visually, but Dataverse, the ones returning data. So that means that the security must be enforced in Dataverse level, not in the user interface here. And we should make sure that this system sensitivity is not exposed as the system grows, right? We should have the settings which are meant for security risk increase. So in order to implement this, we have server-side access control with Liquid. This is something relatively new to come to our lives, building systems with Power Portal, Power Pages, using Liquid and codes and so on. So the key shift here is moving access control from client server-side to portal. And this Liquid template executes on the Power Page server before the page is rendered. This means a user opens a portal. The query itself already respects their permissions. So only the authorized request will be retrieved from Dataverse. This browser will not receive unauthorized data within this way, and there is nothing to hide or filter. So this is fundamentally different. The client-side filtering, where all data is retrieved and you select the show or hide things. And using Liquid together with Dataverse permissions will definitely enforce your security structurally and not only visually. So this allows our portal, internal apps, and Copilot rely on the same trusted security mode, the combining Dataverse and proper implementation of Liquid, and where we have the security of Power Page. We have another pitfall here where we have search bottleneck. So when we have system in the beginning, right, the data set is small. We already touched base on this. We start from a system where the data grows in time. Usually this is a scenario, but of course there might be exceptions. There are systems are actually built with legacies and improved over time. So around month 12 or 18, the system contains, let's say, tens of thousands of support requests. Depending on the scope of the system, this could happen. And we're trying to find similar accidents in the quick find. The performance is degrades here. Now true use declines. So system accumulates experience, but it's not efficient enough to retrieve it, right? We are having slowness again. And this leads us troubleshooting on the repeated issue. So in order to approach these, actually this is a feature that's been provided, but I do think that's relevant to many systems again, is enabling Dataverse search. So Dataverse search will create an index representation of system entities. This allows fast retrieval across large data sets. It improves matching beyond simple keyword equality. This benefits technicians directly and strengthens the Copilot's ability to retrieve the relevant records. So not only for data for Power Apps, but also Copilot touch bases. So this system evolves from passive storage into active operational memory in this way. We will be able to benefit from it, right? Next topic for us is what we call novice silo. So it's actually touch-based to Copilot. We all usually use Copilots to connect documents, not real in our case, is support request data. So it can explain procedures, but it cannot see ticket status or assignments, right? This is not real life data. And here the limitations, again, are textual. Copilot needs to access structural system data to provide reliable answers. And the architectural fix here is grounding Copilot in Dataverse. Means instead of relying on only static documents, the Copilot retrieves real-time system data. So this allows Copilot to understand the current state of what's happening with the support request that we have, the relationship between entities, the operational context behind. So an example that employee asks for, let's say, their laptop request, Copilot can retrieve actual support request record, providing precise answer. And this transfers Copilot from a generic assistant into operational assistant, right? This makes AI actually useful to our enterprise systems. And we touch base to chatbot hallucination, Copilot hallucination, sorry, where we have, let's say, it's connected directly large unstructured documents, but in this case, we have large PDFs. And we are trying to retrieve relevant information, but we don't have a clear picture, clear structure. It tries to retrieve partial unrelated sections. And this leads responses to sound correct, but are incomplete or wrong. It would happen, I think, with many AIs, but let's say in this scenario, we have chatbots. And the example that employee asks for, let's say, a laptop provisioning, and Copilot retrieves a policy for a different device. So there is an inaccuracy on this. And here the problem is not Copilot itself, but our knowledge architecture, where we build structural, scoped, and well-organized knowledge. And we would see this around, let's say, month 18, and our system is already ongoing, right? We have a big scale system, and chatbot is one of the used platforms. And we start having issues and unreliability from the answers we receive. And if this is having a big impact in our platform, our system, having this issue will be a problem too. So in order to build this, we need to design knowledge more intentionally. Instead of connecting these large documents, we need to structure the data sources. And we need to define topics, clear topics. There is a platform for this where you can put proper topics and structure in Copilot. This will give us properly production-grade AI, where we will be able to rely on answers, and this will help us probably, especially a support system like this, very much in action. Next is the ownership collapse. So beginning of everything again, where we go back to the very beginning. The ownership is simple, right? We don't have so many records. So a person, an agent can know what they're working on in the system. But if they are being individually owned, right, and the system starts growing, tickets are coming from very different resources. So we have an increased tickets in the request system. And this will become a nightmare to you because the ownership will become inconsistent. We will not able to understand what is owned by team or system accounts or users in this scenario. And it's the system ownership impacts the security and automation, right? And we will start having some issues within these areas in this point. The root problem is that ownership is being used to represent responsibility when it should be representing access. So to fix this, we'll touch base the team-based ownership model. Instead of assigning ownerships to individual technicians, the agents, we should use the support request owned by support teams. Responsibility should be tracked as separately using an assigned person, let's say assigned technician field. So we can have someone that work on the record that we have, and the team to actually the being owner, so that it would allow us to actually approach the system in a way that we can track where is the data sits, where is the ownership sits, and how these data they are related to each other from also business perspective, not only technical perspective, right? So this will help us the system to grow more stable in time. Our next and last topic is the works in depth problem. I would say that this is actually happening in every stage. It's not only an 18-month or 12 months kind of scenario, but one of the main thing is that if you want to use this platform in a very efficient way with building a scope, like a medium to big scope projects, we need to have separate environments where we work our dev environment separate, where we keep our testing separate. We should keep the process between the deployments between accurate, right? We should not have anything hard-coded in this. This could be a setting, this could be a connection, it could be a link, anything. So we need to have a system where we have a production separate, where we have a live system where we know that things are being tested, being developed properly. And this is maybe one of the easy, clean pitfall, I would say, that visible for everyone, but at the same time, it's one of the most impactful one. So we need to have proper approach instead of doing things and in different environments. And there are scenarios like this where people actually works in their environment and actually even just move things from there to their production. It might be it's a canvas app, right? It doesn't need to be a full-blown system. But yes, this is our last and the most important one. So in order to achieve this, we need to have proper release management. We can use pipelines and configurations. This is where the system is right now. Using pipelines will handle this promotion. We can have environment variables that being used, very useful things. And we'll able to define different things. One of the things very useful is to have this kind of configurational things like themes, queues, and everything is migrated so that you actually have proper stability in between environments instead of actually creating them one more again, because they're very unique records in our system, but also they are relevant to how the system operates. And this will allow us to do safer release, right? The consistent behavior between environments, to have this everything properly and possibly in a way that is stored like with the environment variables, even the connection references to be stored with a pipeline and the settings file. So using many solutions is a very start point, but for an environment like production is very much must. And building a structure where you increase deploy things and move things properly and different release is also very efficient to scale a system and work with the system instead of facing constant crisis. So we came to a point where we discuss 10 different topics. I think these are maybe some of them, right? There are many more I would think of, but let's say that they are high-level ones. But without doing these improvements, we would fail at some point, whether in the 18 months we mentioned or before or after. So with doing these improvements, we will build a system which is more predictable, right? Easier to maintain, deploy, safer to evolve. So the goal here is not just evolve the system for today's problems, but to make sure the system remains reliable, maintainable, scalable as it evolves, so that we would actually grow and the system could grow itself. And so in order to this should mean the team that we should reduce the production risk, simplify deployments. We should make it so the system accepts the changes easier, but also we could do these changes easier. So we should work on the way that we are developing this as well, right? Not only the development itself, and improve and focus on improving the system stability all the time, all the way on the road. So I put like let's say simple structure where we would expect a well-architected system, what should be the key points on this. And so architecture doesn't just determine whether a system works. It determines whether a system is reliable and easy to work over time. And when the foundation of a system is solid, the system behaves more predictably. So this is very important start. And we need to have a system which data can be trusted, automation works as expected, changes can be made without a fear of breaking something else in the system. And again, in ideal world, we should have the new requirements don't force the redesign, right? We don't expect a redesigning, but to grow in the improvement ways. So that should fit an existing structure. Any change comes, any enhancement comes to a system, which happens very often, should able to fit the piece of Lego that you have there and just connect the next. And we need to make Copilots useful. It's growing faster than the other things, I would say at this point. And we should be able to rely on AI in the system and the tools without questioning the outcomes that coming from Copilots. And the good architecture will give you a confidence in a system. So this confidence will help the system to grow and to support businesses and not to slow down. So it will help and faster environment. And Power Platform actually makes it easy to build quickly, but the architectural part is make sure that you build continuous work long after it's delivered. So is the key point where we actually manage the growth. A system, the product will help you to create a system, right, in some scope, but the architecture you put on it will be the one that actually helps you grow and helps you have a system which is long going and evolving. So hoping that it gave you some points and some ideas of what would be the issue. This would be overall my presentation at this point, and I shared my LinkedIn, so if anyone wants to connect, I would be happy. Thank you for the time, and if there are any questions, I guess we can jump to there.
Thank you very much, Tugce. That was an excellent presentation. I do see there was a question in chat. If you're able to see that, it's from Malavika. She had two queries, she said.
1 second.
And if we can't see it, I'll read it out for you.
So, okay.
There's one. The first question was, can you brief about Power Pages? And the follow-up was, you see it too?
I saw that one. Yes.
Perfect. I'll let you take that one.
So I'll give an overview. I don't think we can go deep in Power Page. So Power Page is aka Power Portal. They kind of sit almost the same right now. It's actually what we were seeking in Dynamics for a long time, where we have an flexibility without concern about, because Canvas has more focus on mobile applications, but Power Page gives us a flexibility to build up actually a website on top of Dataverse, SharePoint, and external sources, but it works in the Azure AD. And it will allow you to have AD authentication or an external authentication, but will give you full flexibility whether you want to choose a Dataverse structure and forms, or where you will actually able to build on top and have very fancy looking forms, which is very much used currently, I would say. So that's a brief, and if there is further question for Power Page, I can answer. So the ideal world would be that, this is for a second question, that we would have data growing in time. But there are, of course, systems that data is handy in the beginning as well, so it depends. But after, let's say, data might means master data, means that you actually get some data sources and include to your system. And data also might means the data that you built in the system, right? That what we discussed is requests. And as much as you use the system, right, the system data will also increase because you start putting more requests in the system. You start putting more relational data in the system too. Let's say you have a lot of activities happening around it, so you have a lot of things like emails, SMSs, and so on. So within this, you would expect the volume to becoming large, right? We are not necessarily talking here as big data, but the volume is large for a system, and if it's not built consistent in a way that data can be stored, present, because we touch base forms, we touch base other things, then you would have a slowness in the system. But data and usage of the system is very much dependent for the needs of the projects, for the scope of the projects and the usage, because you might have a system which you use for just 100 people. I had such a scenario. Or you might have a system which is used for thousands and thousands of users daily, which is something that I'm going through now. So depends. I hope that gives an answer. Any other questions?
That was a pretty detailed answer. If anybody else has a question, please come off mute or type it in. All right, I guess we don't have any questions, so we can begin wrapping up. So first of all, Tugce, thank you so much for joining. Thank you for the wonderful session. I